Hey, good afternoon, everybody. Thank you guys so much for joining us today. It was great to see you guys at the IMC conference last week, and we're excited to kind of continue those conversations that we had last week and dive a little bit deeper into the OnTrak Wireless on today's webinar. I'm Maureen Gribble, so hopefully I got to meet you guys last week. And Blair Frazier, who you also hopefully met, is going to be doing the heavy lifting here. But just want to welcome you guys and let you know a couple kind of housekeeping things. We are recording this, so we will be sending you guys a link to this recording when we've got it up and ready to share. So later this afternoon. So if you need to share this with any of your colleagues that couldn't make it, or if you've got to hop off early, we will make that available to you. We highly encourage this to be as interactive as we can make it, considering we're all kind of spaced around the country, but or the continent rather. Blair is up in Canada. But if you want to pop questions into the little questions box, I'll be keeping an eye on those. I will toss those to Blair as it makes sense. If we need some clarification around something before he moves on, we can do that. And of course, at the end, we'll have some time. If we don't get to everybody's questions, we will for sure, be following up with you offline so we can get those answered. And again, we are doing this live, so always like to remind you, if we have any technical issues, if audio drops or Wi-Fi gets wonky, we'll try and square that away as quickly as we can and get moving. But with that said, Blair, we see your screen, so you are ready to just rock and roll and take it away.
Perfect. Thank you. Thanks, Maureen. That was a great intro. And yeah, pleasure to talk again. If we didn't meet in IMC, my name is Blair Fraser. I'm the VP on the technology side, and very excited to be talking in more detail about the OnTrak Wireless. And hopefully you guys have some good questions for me. I'm going to try to cover a lot of material. Presumably a lot of you are already ultrasound users, and we appreciate that. So some might be a little redundant on how ultrasound works, but just in case, if there's a few on here that might be new on their journey of ultrasound and where it fits in, we'll cover some of the basics of that as well. I guess one of the big things that came out of IMC was we were honored to receive the Solutions Award for the Best Lubrication Solution of 2023. We're very proud and honored to receive that award. I think it gives us and the engineering team the kudos around what we've been able to build in the market. In fact, the solution board was given to us from our wired OnTrak solution that's been out for a couple of years, and what we're going to talk about today is the next evolution of that, of moving over to wireless. So hopefully you'll see this logo again on the awards for our wireless product. And when we really think about the OnTrak and why does it exist in the market, and the reality is we have feedback from our customers saying it's about time, and I say that with a smile on my face because really, the industry, customers like you have been asking for the interoperability, the connection of single point lubricators and ultrasound guided lubrication. Why have those two not been married in the past? And we've been looking at it in our engineering development pipeline for a long time, and really until the advent of Industry 4.0 and the availability of connections and things like that, it just wasn't at a scalable level until we were able to bring in Bluetooth and gateways and things like that in order to scale it. And really the why we won the solution award for the lubrication, well, it is a condition monitoring system. And I know from at IMC and other conferences, there's an abundance, if that's the right word to use, of condition monitoring systems that are out there to tell you when to have a defect. But really where we see the benefits, and where the customers see the benefit is on the lubrication piece, the lubrication side. So you're going to hear me talk a lot about not only detect but prevent of what Terence O'Hanlon will say is moving to the left of that P to F curve to be able to prevent a failure before we need to detect it. And then why do we focusing so much on prevention is because now this is a study by SKF, and there are other studies out there that have similar numbers. So I think some are as low as 60%, and this is obviously up as high as 80%. That up to 80% of premature failures, bearing failures, can be traced back to a problem with lubrication. And when you think about that, most of the time what we think about is over or under lubrication. And really, when you look at all these studies, what it talks about is these four main things. It's the right grease, contaminant-free grease at the right time in the right quantity. And so you look at those four things, and until now, there's been different technologies to address all four of those things. And this is the way I look at it in my career, and I've been in this for longer. I want to admit now, and at one point in my life, I jokingly say I did work for a living. I did go out and lubricate bearings, and I knowingly now went and lubricated all those bearings based on time very incorrectly. And I was a believer that if it was a long weekend, I would give it a couple extra shots because I didn't want to get called in on the long weekend. So I'm not going to go back to that employer and pay them back for ruining their bearings, but I've definitely learned. And what I was able to see over my career is, there's still companies doing whenever lubrication. I'll get to it when I can, or when the OEM tells me to. And if you look at the evolution of that, what we were able to do was use some calculators. And then there's a lot of calculators out there that, depending, might get you in the ballpark of the regreasing frequency and quantity. And actually at IMC, we did a workshop together where we played with those variables. We changed one simple variable of the humidity by 1% humidity, and it changed the greasing intervals by about 30%, by 1% change in humidity. So we know there are some limitations with route-based. And if you look back at that previous study, with route-based, you still have, you're connecting to Zerk fittings, you're doing it based on time. So there's a lot of things that could potentially go wrong. 3 and 4 really came out close to the same time. We have been in ultrasound for 50 years. This is our 50-year celebration of bringing ultrasound to market. And we've had condition-based lubrication out for decades, different various models of technology. And that's essentially, we're listening to and monitoring that friction in the bearing and lubricating only when needed and giving the exact quantity of grease that's needed. But we're still using a grease gun. So we still have the opportunity to introduce the wrong grease. We still have the opportunity. In the saying I was once told about a year ago, said, Blair, have you truly seen people walk around and wipe a Zerk fitting? And if they do, are you using the same rag on every single one? So we still have that ability to add contaminants to it. And that's even with our grease caddies. There's still a pitfall of using the wrong grease and putting contaminants in. Now, single point lubricators have been out for a long, long time as well. In fact, over COVID, the use of these went up exponentially. Because people weren't allowed in plants, people had to stay home sick, and those type of things. So the use of these came out, and from our experience talking with people with single point lubricators, is they're a love-hate relationship. Either they've tried them, they threw them out, or they tried them and they only put them where they're absolutely necessary. Because why? Well, they're still based on time, and there's some have been a little bit smarter, and they've added what I call earthquake switches to them, so they can start to be dynamic in some of the variables, such as runtime. So the lubricator doesn't lubricate when the machine is off. But generally, they're pretty unintelligent devices sitting out there, and they're all based, until now, based on time. So what we've been able to do is now bring the benefits of removing the guesswork of item 3 here with route-based, condition-based lubrication, and combine that with the simplicity, accuracy, and contaminant-free ability of a single point lubricator into one solution. So really what we're looking at is in the market, and I think there was, in my count, there was 15 detection systems at IMC, which is great. I think absolutely, we know the benefits now of talking about time-based maintenance and moving to condition-based, whether you agree with the terms of condition-based or predictive-based maintenance. The intent, and that was driven back from RCM. RCM taught us back in the late 60s to early 70s of the P to F curve, which is now the D to I, or the S to D to I to P to F curve. And what that P to F curve has taught us is that point P is identifiable physical condition. So there has to be something going wrong with that bearing in order to detect it. It's something I call the race to detect a failure. Now, we're not here to debate where ultrasound detects earlier than other technologies, but the concept there is that there has to be a defect, and that goes in that detection phase. And where this OnTrak wireless system fits in, absolutely, we use ultrasound to detect, early onset of bearing failure, but we also use it equally to detect the earliest signs that a bearing needs lubrication, and that's what we call the prevention. And that's where the OnTrak wireless sits. And it was interesting, we were talking with a customer earlier saying, well, I'm a government facility, I have to go out to bid on this solution. I said, that's great, but you're not going to find another solution that combines both the prevention and detection. So we can bid it 3 times if you'd like, but right now we're the only ones that combine that detection piece with that prevention piece. And I have undoubtedly that just based on the demand in the market, that there are going to be others bringing this solution to market. And I can tell you, we've got a 3-year head start. It's interesting as we look at the wireless sensor, I jokingly tell people I could tell you at least 52 ways not to make a wireless ultrasound sensor, because it has been a labor of love for the last 3 years on making the sensor and bringing it to market. So really the value proposition of the OnTrak wireless is moving beyond monitoring. And I use simply monitoring as it's not meant to be disrespectful, but it is something that we're really trying to improve in our maintenance strategies of prevention versus detection, right? So we're really focusing on that monitoring piece, but as well as focusing just as much effort on eliminating that failure from happening in the first place. And again, how we do it is fundamentally this system, and you're going to see how we combine other technologies in this discussion of why adding vibration and temperature makes sense and where it complements things, and also where we're not, where we don't see us playing very well, and there's reason for it. So as ultrasound being our primary measurement, we are to the right of the identifiable physical condition of looking for that early bearing defection, what NASA called in their study that determined ultrasound was the best at detecting that earliest fault. They called it the detection of an incipient fault in that study. And also that use of ultrasound to really remove all the guesswork from lubrication. What ultrasound allows us to do is answer the question of when grease is required and how much grease is required. So when we look at this system in a whole, there's really 4 main components. And if you are an existing OnTrak wired customer, we do have another webinar coming up where we're going to talk about that transition plan, if it makes sense for you to move from the wired to the wireless. It's important to note, and if you've seen any of the material, I've had a discussion about the OnTrak wired, for the right reasons, we've completely reimagined this product. There is nothing, we started from scratch. We've taken the thousands of sensors we have out there. We've taken the literally, I think over now, we're probably over 30 billion data points that we've been able to collect over those 3 years and make sure that any challenges, pitfalls that we were able to engineer out and the benefits we were to see, we see with those wired, we could exemplify them in this new solution. So everything has been built from scratch over again. There's not one piece of code, line, hardware that is used. So at the heart of the new OnTrak wireless system is the 950 BT. This is a wireless ultrasound vibration speed and temperature sensor. So with the wired sensor, we were able to bring out that overall friction, that overall dB level. Because we were moving to wireless, we're able to efficiently package more information into the data sets that are coming out. So it's important to note as we go through this, and I'll talk about this more as we get to the details on the wireless sensor, it is an ultrasound first sensor. So our primary measurement and what we're looking for is ultrasound. We complement that with vibration, speed, and temperature. We've completely reimagined the lubricator as well. We have true 2-way communication with this lubricator. So if there's an error, and there are errors that can happen, one of the most common things that can happen as these devices are sitting out there is there can be a number of reasons why grease won't flow into that bearing. Grease can harden, it can get removed from the bearing. So instead of just having an error code pop up on the screen with the LCD on the device, there's a limited number of characters we can do. So we have to use error codes. But what we can do now is we can decipher that error code. So we can measure, and we are measuring things like the current draw on the motor inside the lubricator. Why do we do that? Well, what happens if it's starting to draw more current? Well, we're starting to receive some back pressure. Is that indication it's getting overfilled? Absolutely. Is that an indication that it's clogged? Absolutely. So we get more insightful information from the lubricators. And we do have a new gateway because we're wireless. So we have a gateway, a very powerful gateway that we're doing a lot of the processing of the data at the edge. So this gateway is more than just collecting data and repeating it out to the cloud. It's actually processing that information. Set points, baselines reside in this gateway for two primary reasons. One, if we ever lose communication with the cloud, that information still resides locally. And we see a high need in industry in order to collect and transfer insights, so not data, insights, to host systems like PLCs, DCSs, those on the plant floor. And that's how we do that. By aggregating and analyzing the data at the gateway, we are able to get that information. If you have an Allen Bradley factory talk system, if you have Johnson Controls building automation system, if you have a Delta V DCS system, and I can name these forever, right? We can easily communicate into those platforms so that people don't have to learn necessarily from a overall asset health and needs of their bearing. They don't have to learn a new platform. And then our new UE Insights. This has been completely reimagined under the premise of building an enterprise level solution. And the reason I say that is with the existing UE Insights, it served a purpose. This is a dashboard built for remote monitoring and lubrication of your bearings. That's it. So we had to design this to get data out into other cloud systems. So other, you might be doing AI systems, or your company might be building a remote monitoring center, things like that. So we wanted to make sure that every bit of data that comes into our platform, we can easily get that out. And the ground truth of the new software is that enterprise level. So while we encourage and welcome a lot of discussions with IT, we understand, and for the right reasons, those are very tactical and sometimes heated conversations. So we built this platform based on the requests of our thousands of customers on the wired. Solution is, can I have two-factor authentication? Eventually, can I get to the point where I have a single sign-on? The same login credentials I use for my computer to log into my network, can I use that to log into this platform? And the answer is yes. We have built it to ensure as many check marks out of the box, if you will, from an IT security point of view is checked off before we have to go to battle with IT. And I say that respectfully. So internally, what we've done, and this again, if you met me in IMC and you met me the year prior, you would notice a little less hair and a little more gray hairs. And the reason being was because of this product for the right reasons. And what we do internally is we have two stages of testing. So we have our alpha and then our beta. Our alpha is internal, our lab testing. We have labs throughout our regions that we do very extreme testing through incubators for temperature changes, for inducing noise and things like that to make sure that our equipment is repeatable, accurate, and sensitive across all of our products. Once we're confirmed with the alpha testing, we move to beta testing. We've been in this beta testing for longer than I'd like to admit. And as I said, I can tell you 52 ways not to make a sensor. And this really comes with, we have difficulty within the lab simulating what a real life industrial environment's like. So we take these out to our early adopters, our beta customers, and get them through the test. We get them through Canadian winters. We get them through outside through tremendous amount of rain, things like that, we're not going to bring a fire hose into our lab in New York. So this is one of our customers, to give you an example of how the system looks. And the first thing you might notice is, gosh, that sensor looks like a little odd on the side there, right? And it is, and it's designed like that on purpose. Now, if you're familiar with ultrasound, you'll understand why we're doing this. And what I want to talk about here is just the mounting methods that we have and what the system would look like. So if you look, and if you can see my mouse, this new adapters called our grease fitting adapter. And what we found was with the wired installation, because you're running cables, is a very labor intensive process. And one of the things was how can we quickly mount these sensors and still get a reliable, repeatable, and high amplitude signal from the bearings. And this grease fitting adapter was an example of it. So on larger electric motors, that grease tube that's existing in the motor goes right down into the bearing. It allows us, when we put on its adapters, it serves as a wave guide for ultrasound. That ultrasound will come up that grease fitting from the bearing. We're not going to have to resonate through the casing of these big motors, and it gives us by far a very, very strong ultrasound signal. We do sacrifice a little bit on the vibration side, so that is a give and take relationship. Again, we're not using vibration as a primary measurement. We're using ultrasound. We're using high fidelity. If any of you are familiar with grabbing the audio signal from any of our handheld ultra probes, grease caddies, or our forecast of the benefits of that high fidelity time waveform, putting it for an FFT, we're gathering all that in this sensor and you have access to it. So very powerful from that aspect. If you look at this picture, and if you see my mouse on the left-hand side, you'll see a fin mount. What we're doing there is we were testing the different mounting methods. So we can still use epoxy mount, we can still use fin mounts, and we have the option, if it makes sense, to use this grease fitting adapter. And as a note, all these pictures I'm showing you now are what we call direct mount, which means the lubricator is directly tied into the fitting with the sensor. We do have the ability to mount this lubricator up to 20 feet away and run remote grease lines into this fitting. We have a different fitting that has, I believe, a 1/4 inch thread on it, so we're not using adapters. So we can still mount this lubricator in a remote location 20 feet away where we can access and service it. So as we look at the sensor, and as I said, this was really the heart of what took the most time to release this, is internally we have a standard with all of our equipment to be ±1 decibel of our standard, which is incredibly tight, which means if you take a measurement from an ultra probe and you take a measurement from our sensor, we want them to be similar, given the same mounting methods, of course, right? If you take one with a magnet and one with an epoxy, you will get different readings, obviously, and no different than any other technology. So it is an ultrasound first sensor. We use that, and there is something I'm going to talk about, which is, in my opinion, is groundbreaking to what we've been able to learn from bearing health and lubrication needs with the wired system. We did add the vibration, both from the velocity and the acceleration point of view, to really tackle or identify faults that might not resonate with ultrasound, that will resonate with vibration first. And we added temperature. In fact, where I have that circle on the bottom of that base, and I don't have a banana for scale, but the base of this sensor, and if you're familiar with our wired ultrasound sensor, or even our RAS sensor, which is designed, you'll notice that there's a bigger metal base on the bottom. And the reason we have this base, which you may not see with other vibration technology, is because we know the exact weight of this. This is engineered to be precise measurements to resonate at the frequency we have the ultrasound sensor at. So it gives us that reliable reading. So it is different from what you would see from other sensors, and that's the reason why. One of the biggest challenges we had with this sensor is on our engineering development, is when we talk to customers, and we are actually going through, and I think if I look at some of the names, some of you on the call today, we are going to be meeting with some of your team members in what we call a technology information exchange, in terms of helping us define our roadmap of where we're taking this technology next. And when we've done this previously, one of the biggest benefits of ultrasound was the ability to hear it, the ability to simply, compare bearings, and especially as you're validating your results to people that might not be technical, you can play a sound from a bearing from a healthy bearing and an unhealthy bearing, and people can immediately, without any training, hear the difference. That was lacking in the OnTrak wired because we were limited to the one protocol that we could send information out. Well, with wireless, we weren't in that limitation. So we set a lofty goal to be able to develop a sensor that we could capture, record, send a high fidelity audio signal just as you were standing to that bearing with an ultra probe and listen to it. While we don't have a headphone jack on this, we do transmit that wirelessly into the platform. There's a latency about 1 to 2 minutes where you can capture that audio signal, you can play it back and hear the sound. But to take it one step further, you can take that just like you would with your ultra probe or your forecast, bring it in a spectralizer and do a full analysis. You can take that time waveform, do an FFT, do waterfall plots, set up your ball pass frequencies, all that stuff you're used to with our ultra probe, you can do it with this sensor. And that was probably the heaviest lift to get that fidelity. We're sampling at 22,000 times per second to get that information from an audio perspective and send it. And that was a very big feat for us to do. Then when it came to the louver, as I was talking about, our whole goal is to bring confidence back to these devices and restore the name of a single point lubricator. So we do monitor the grease level. We have two-way communications. In fact, our sensor and our lubricator, even if they're not transmitting data, we are doing a handshake with them. Say, hey, you still there? Yep, okay, good. Right? You could do that for decades. There's very little bandwidth of saying, yeah, I'm here. So if a sensor was to move, get powered off. We have seen it where you might have a maintenance overhaul event, take the lubricator off, power it down for some reason, and forget to put it back on. Right? We'll pick that up right away, even before it becomes time to grease the bearing. We do sense the back pressure and we get that feedback into the platform. So for some reason, the grease line was to get clogged, bearing was to get clogged with old grease that may have resided in there. We get that back. And with the sensor and the lubricator, we measure the battery. We don't measure the battery voltage. Well, we do. And if you want access to it, you can do it. We actually give you a battery percentage, which is on the battery curve, because it dies a lot like a rock falling off a cliff. It's good, 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 and then that voltage drops. So we give you a battery life. And I'm assuming one of the questions is going to be a battery life, which we'll address this at the end. So when it comes to a holistic solution, now we're looking at this from a motor perspective, and if we have pumps, we can look at cavitation and things like that. But really what the intent is to look at the detection piece, and particularly the vibration piece, which if you look at the bottom right-hand scene, which is a machinery fault, so that's where things that happen to the asset, the machine itself, really resonate first in vibration, then will resonate into ultrasound into the bearing. So if we have misalignment, mechanical loosening, imbalance, belt issues, things like that, that will detect that with the vibration side. And the prevention, the lubrication, early bearing defect, we rely primarily on ultrasound. But you'll see as we get into our dashboards, and if you would like a personal tour of it, we can walk through in more detail. But for example, we'll plot the friction as well as the vibration bearing defects on one plot. And what we typically have seen from our beta testing is ultrasound will pick it up. Once the fault comes to a certain level, we'll start to see the harmonics, the bearing frequencies happen in the vibration side. Right? So combination of those two are very, very important. And for those, excuse me, those that aren't familiar on the lubrication side, and if you are a tribologist and MLA, MLT, you would understand this quite well and likely do a better job than I would do explaining this. But essentially, what we're doing in this platform is we're gamifying something called the Strybeck curve. And what the Strybeck curve has taught us is there's three regimes, as they call it, across the lubrication of a bearing, boundary being metal to metal. So if you look at the friction, there is no higher friction you can get in a bearing than metal to metal, right? There's no grease, there's no oil. As you start to add grease, you get into this mixed domain, your friction level drops, your friction, or as you add grease, it goes up. What's key to remember, and this is what's very unique, is while we can detect lack of lubrication, we also detect the over lubrication. I'll show you an example of that in real time of how that works with ultrasound. And if you notice, and excuse me, if you know the Strybeck curve, this is the best I could do with the limitations of PowerPoint to draw this curve. Is not exactly proportional, but even the most overfilling you can do never reaches the level of friction of mechanical to mechanical contact. So what we're doing is, and imagine you have a bearing, you say, Blair, I'd love to put these sensors on, but how do I know where I am in my lubrication health of this? And there's a bunch of things we do just to look at the overall health of the bearing even before we do anything. So do we have, that earthquake vibration chart, the ISO standard from a velocity perspective? We'll look at basics like that. Excuse me. But from a lubrication point of view, so if I was to draw a line here, and let's just say for argument's sake, this was at 20 decibels. So we're measuring that friction, this is at 20 decibels. So I either could be here or here. It crosses that friction line twice. How do I know where I are? Well, what we can do is put a little bit of grease in. If you put grease in here and it drops down, you're under lubricated. If you put grease in here and it goes up, it's over lubricated. Now I'm simplifying it, but that's really how this system works. And what we've decided to do is, learning from that 20 billion data points, was we have a more accurate way of telling us where we are and distinguishing between a lubrication, I guess, defect or fault versus a true bearing defect. And differentiating between the two is very, very important. So what we're doing is we're essentially monitoring that bearing friction in real time. We're constantly monitoring it. The moment we say, hey, you've crossed that ISO limit, the system's going to automatically go in and apply grease. And when I say automatically go in, there is a human in the loop mode, which means it will only lubricate once you give it permission. But there also is fully autonomous as well, that will automatically lubricate your bearings. And our findings from that 20 billion data points is very telling, I believe, of how we might have been servicing our bearings wrong. So in our head, and actually what we're working towards in the next firmware update of our software, is actually having a live chart of that strieback curve, which I think we can accomplish. So what I'm going to show you next, to give you an idea, just in case you're not familiar with how the technology works, and I want to show you how a bearing gets lubricated using ultrasound guided lubrication, but in a manual aspect. And for those of you that know lubrication, you're going to see a few things that happen that are incorrect or not best practices with this. So I'm going to play this video, and what you're seeing here is a chart from DMS. So if you do use our equipment for handheld, typically you do it every month. Some do it more frequently based on the criticality. That friction level goes up, you lubricate, and it goes down. If you were to look at the raw data behind the scenes, and this is the exact information we can get from this sensor, is we can capture this. As you can see here, you have a high level of noise, high level of friction, grease hits the bearing, it drops down, it goes quiet. So as you watch this video, there is no sound. You don't need sound because it's just background noise from this facility. Keep an eye on the ultra probe, keep an eye on the value. So what's showing up on the front of the ultra probe is a decibel value, which is directly correlated to the friction in the bearing. I don't know the asset, the operating context of this bearing, but this gentleman is going to apply grease into this bearing. So as he's applying grease, you can see here we're starting off at about 57, 58 decibels. So what you can presume now, he's filling the grease line, he's getting into the zerk fitting, he's got to start moving grease into the bearing. So keep an eye on that number. So 57, 56, he got a little tired there with his forearm, right? If you look at his eyes, he keeps on looking up every now and then. So what do you see happening right there is that aha moment. It dropped from 58 down to 42, 43. He's looking at us right now. What's he continuing to do? He's continuing to lubricate. So we missed that ideal spot on that strieback curve. Well, I don't know if they did this on purpose. I don't know where this was, but he kept on applying grease. So we started at 58, got it down to 42, ended up at 46. So we actually went a little bit too far on that strieback curve. And for those of you, I can't see the chat here, but for those of you that may have commented, or at least in your head, I would question the rate at which grease was applied as well. You know, that grease gun can put anywhere from 8 to 15,000 PSI. I'm glad it's not a DeWalt automatic greaser, or else we'd likely see grease hitting the guy's, I was gonna say safety shoes, but those are like running shoes, but that's not the point. Right, so even with the best intentions, the best technology, it is human error will always play a part. And this system is really designed to remove all that guesswork. The system, if I look at that bearing, our OnTrak Wireless would probably take 30 to 40 minutes to lubricate that bearing. It's going to put a little bit of grease in, which is completely controllable. How much grease goes into that bearing? Anywhere from 1/3 of a cc or 1/3 of a gram up to 2 grams at one time. I wouldn't recommend starting with 2 grams. We always start with 1/3. Depending on obviously the bearing size and the speed, then it will change those factors. And you can change them at any point. It is going to take a while. It's going to put grease in. It's going to wait for that grease to get pushed around that bearing. It's going to take readings while grease is going through that bearing. So we don't stop taking readings. While grease is getting slushed around that bearing, it's going to continue to take readings. In fact, what our sensor does is it's designed to be configurable in terms of when it takes readings. So by default, we recommend every hour. So every hour, sensor's going to wake up, take an ultrasound, take a vibration, take a temperature reading, all the good things that come with it, and send that information out. It'll likely get pushed to later, but 1 hour is pretty good standard. If you had to wait an hour every time you put grease in, we'd be here to 2025 to lubricate that bearing. So just like our wired, if you're familiar with that, what we do that's very unique is we turn that sensor into fast sample mode. So instead of updating every hour, it's going to send you the friction, the vibration every minute. So it's just like we're standing beside it. So we can see bearing grease going into the bearing. We can see what's happening as that grease goes through the bearing. And then it's going to make that decision. So what that looks like from the new UE Insights platform is similar to the previous one, where we're monitoring that friction. We have a friction lubrication level, a warning level, and those are based on the ISO standard. So there's an ISO standard that tells us that 8 decibel increase over baseline is the first sign that your bearing needs lubrication. Now, I believe with our data, we can challenge that and we can get more precise with that 8 decibels. I can also tell you that on slow speed bearings, that 8, 16, 35 decibels is not recommended. In fact, we got to get a lot more aggressive with that. But as that friction goes up, the system will kick in, it will lubricate that bearing, and we'll do it for you. If we can do it for you as well, that friction will drop. It will drop at a rate that is exponential in terms of dropping, just like we saw on that Ultra Pro. If you look at the orange line, what is that telling us? And this is fundamentally what we're able to come up with, and I believe rethink how we use ultrasound. And the reason this came from the OnTrak wired system is this only works if you have a system that's taking continuous measurements at the exact same location, exact same mounting at the exact same time. If you were to do this on a route-based, you would not have the repeatability, and trust me, we have tried this. So we have 2 variables coming up, something that we've called friction sense and impact sense. So friction sense is what you're familiar with. Friction sense is that overall decibel level that's directly correlated to that friction in the bearing. That is primarily 99% of the time what we use to look at the lubrication needs and health of our bearing. We were able to see through that 20 billion data points and create a very unique algorithm that looks at the impacting. So what we do on that raw time waveform is we calculate the number of impacts that are happening in that bearing. We don't just calculate the number of impacts, we calculate the number of impacts and the amplitude of each impact. Why is that important? There might be, isn't that similar to crest factor? In crest factor, yes, crest factor uses the highest peak out of that time waveform and compares it to the RMS. So if you have one thing that went bang in the night, and particularly we see this on industries that may be in pulp and paper or machine manufacturing, where things aren't steady state. You're not just pumping water, right? That one impact can change everything. But if we measure all of them in the amplitude, one of them doesn't throw us off. So fundamentally, what we've found and been able to bring to market is this. So we give you that friction. That is the overall decibel level in there. As you can see, this is the 2 exact same bearings I'm about to show you. So what we see here is that time waveform taking at 22,000 times per second. What you can see is as a bearing needs lubrication, the friction level is high and the impacting is very, very high, as you would expect. And if you were familiar with listening to ultrasound, you would know what this sounds like. As you lubricate, that friction level drops, but on a healthy bearing, that impacting goes away. So our friction level drops within ISO standard, and this impacting, which is a unitless number that we've been able to come up with, drops down. On unhealthy bearings, we put defects into this bearing. That friction level when it needs lubrication, again, very high. It's actually higher than its twin brother. The impacting is still very high. When we lubricated it, it went down to within ISO limits, which is great. not quite far as down. So if you look at this, this went down to 10, this went down to 16, but the impacting never went away. It got reduced, but it didn't go away. So the impacting is still high. So I can tell you with a high level of confidence that this is very, very early onset of failure. I would not recommend replacing this bearing, but I can tell you with 100% confidence that the grease frequency and quantity of this bearing is going to go up. You are going to need to grease this bearing more frequently in order to keep those impactings to a relatively manageable limit. So I'm not telling you this is an inner race defect, outer race defect, those type of things. Excuse me. What I'm telling you is the addition of this impacting factor or impacting sense is going to provide you a lot more information to the health and lubrication needs of your bearing. And then, of course, if you're familiar with our spectralizer software, that ability to grab that time waveform that you're used to, put it through a time series, put it through an FFT, zoom in, put bearing pass frequencies, all those information is 100% possible with this solution. And then from the, I call it the enhanced insights or the complementary measurements we're doing from this perspective, is we are measuring an overall velocity. It is a single axis sensor. And if you want to discuss, we can discuss why we did single axis versus a triax. It's a single axis sensor where we're looking at the measuring the velocity, and we typically use that to plot it to the ISO standard for compliance of machines based on the machine class. We do grab the time waveform. We do an FFT in the sensor itself. So we're not transmitting that full FFT. What we do is we set 4 narrow bands or what's called narrow bands, alarm bands on that FFT, looking at very specific faults. So typically 1 times order, 2 times order, maybe bearing harmonics and something on the electrical side if it's a motor, to give you an example of that. So all that gets set up. So we have that ability to look at those misalignment, soft foot, mechanical looseness type faults very directly. We do calculate the speed from the vibration signal. So again, this isn't a tachometer. We're getting plus minus 10%. And as we're testing in development, we found that that is enough accuracy required to give us dynamic alarms. So if you do have an asset that varies in speed, we can set our alarms dynamically. So based on the speed, if it's between this range, these are our alarm rates. If these are this speeds, these are our alarm rates for these, and dynamically do that live. And again, we do have the surface temperature. Again, it's surface temperature, so we have to resonate through the bearing housing and things like that. And we use that as a condition to tell us, and we do see, depending on the rate at which grease is going in, we'll see that bearing temperature rise. And obviously, I think we know that if you increase the bearing temperature, you're significantly reducing the life of the lubricant and the bearing itself. So we use that as really a tertiary measurement to make sure that grease is getting to the bearing and the health of the bearing and those type of things. Now, as we get to UE Insights, as I talked about, it is completely revamped. It's like we started from scratch. So we've built it as an enterprise level solution and given you a framework to build up a hierarchy that makes sense for you. So we can start at a corporate level and go down a tree hierarchy like you would for your ERP or CRMS system and group all the bearings to assets, assets to systems. So at any level in the platform, you can click on any system or any asset and get the overall health, or any building, any plant. We have the ability to geomap. So you can have a Google map, and if you have multiple buildings, you can just look at the map and literally one of the buildings will go red. Oh, this has an indication, right? Those type of things. So we start with insights and we move our way down to data. So we have dashboards built, and these are customizable. They are made through widgets. So if you would like a dashboard built, you can build your own. We start with insights. So do I have misalignment? Do I have electrical? Is my friction good? Do I need grease? Those type of things. And we move down to data. So at any point, you can click on these variables and move your way down to data. What is very unique with this offering and what we found with the Wire is even the best run companies from a maintenance reliability aspect have challenges dedicating resources to this. One of our biggest challenges we have in industry is obviously labor. So what we've done differently with this OnTrak Wireless is we offer it as a solution. We offer it as a complete solution, meaning we do the commissioning, we do the install, we do the commissioning, we do the setup, and we do the monitoring. So we have built over the last couple of years is a team dedicated to this product vibration level 3, ultrasound level 2, MLA, MLT people to assist you with the data analysis piece. So we're constantly looking at this data. When alerts come in, we're going to make sure you receive them. We're going to work with you to resolve these. And the way we do that is we built it into the platform. So if we're going in through here and we notice this is the bearing temperature, hey, this temperature is high, and let's just say your name is Bob, we'll post a condition notification saying, hey, this bearing's high, this is what we recommend to do. You can acknowledge it, which means I've received this, but you can communicate bidirectionally with one of our experts saying, hey, yeah, I noticed you said this is high. Could you try doing this, or what do you think about this? And have that conversation with one of our experts. With this subscription and solution as a service, you have a dedicated customer success person, so you can always reach out to them. But we didn't want to be phone calls and emails as limitations. So you can have that communication through the platform. You can acknowledge it saying, hey, I've noted this, thank you, but I'm going to get this aligned during the next shutdown. And once it gets resolved is when it's fixed, and then we can go back in and set baselines and all that kind of stuff. So we try to do all the heavy lifting we can for you and try to make it as turnkey as possible, from installation, commissioning, data monitoring, fault resolutions, everything like that. Now, because we have built up a database of 20 billion data points and growing every day, we have seen good bearings being lubricated. We've seen bad bearings being lubricated. We've seen bearings that have been replaced with bearings that are in worse condition than the ones that are being replaced. And unfortunately, we are starting to see a number of counterfeit bearings. And apparently that is coming from the supply chain shortage that happened during the pandemic. And we're starting to see instantly when you put in a counterfeit bearing, the friction level is just off the charts. So what we do is that I'm not sitting here saying we have some magic algorithm running that's going to say, hey, you have 6 days, 6 hours and 23 minutes before this bearing fails. That's not the case. But what we do is, because there is 30 data points coming from each sensor, is when you think about it from a friction and impacting, all the vibration information, the temperature information, knowing when it was last lubricated, all that information gets processed and put through anomaly detection. And what it's trying to do is identify outliers, saying, hey, based on everything you've taught me over the last month, 2 months, depending how long we need to get appropriate baseline in, this is starting to drift off at this rate, and these factors are the ones that are contributing to it, right? So it's not meant to give you decisive. It's not actually going to create an alert. It's going to create a warning. And then what we do is then our experts go in and try to determine if that's valid or not. And if we do detect something, we can then label it and say, hey, this is cavitation. Next time you see this, warn me that this is cavitating. Is a great example of how this platform is coming together with an AI perspective. And then one of the big enhancements we're bringing to market is, with this platform, is not only do we foresee the OnTrak data, so the bearing health and lubrication status of your bearings coming from the OnTrak, but we want to integrate that in with the UltraProbes. If you're familiar, we released the new 15,000, which has built-in Wi-Fi, which will natively talk to this platform as you're walking around a facility. But we do have it in 2024 to bring existing UltraProbe data through the SD card into this platform. So whether you're taking the data route-based on a monthly basis, or you're doing it through the OnTrak, or if you have a grease caddy, particularly a 401, you can bring that data in, so we have one platform to monitor all your health and lubrication needs of your bearing. And to give you an idea, and I'm going to go through pricing here next, so hopefully that'll address some of your questions, is the new gateway can talk up to 40 devices. So a sensor is a device and a lubricator is a device. So essentially 20 bearings. It can go up to 1,300 feet. For us outside of the USA, that's about 300-400 meters. That's an open space, ideal conditions. We're looking at around 300 to 400 feet, about 100 meters. I'm going to tell you the distance doesn't matter. And the reason for that is we decided we're not in the business of supplying gateways, right? We're an ultrasound company. That's where intellectual property lies, and that's the value we're bringing to you as our customers. So what we decided to do is provide pricing per bearing. You just give us the number of bearings. We will work with you on asset selection to make sure it's the right fit based on how the solution works. but we will supply the number of gateways that are required based on our limitation of 40 devices, but also available receptacles, the distance. We'll supply as many gateways as required to make sure you have a robust, reliable solution in place. That information from that gateway can go out Ethernet, Wi-Fi, or cellular. So we can hop on your network using Ethernet or Wi-Fi, open up ports, firewalls. We can skip that all together and go cellular. We do have two options. One, we have a cellular SIM card that goes in the gateway. If you have multiple gateways in the same locations, we can use one as a router and just have one location sending that data out for optimization from that point of view. And I'm very excited to announce, if there is a need for it, we do have power over Ethernet option, which means we don't have to get a receptacle to this gateway. We can actually power it over Ethernet, work with your IT department and provision it that way, so they control, the traffic going through and all that kind of stuff. And it does check a lot of boxes on the IT security point of view. So power over an Ethernet is an option. So as we get to pricing, and this is unique to us, and it's been well vetted in the market. And if we did have a discussion, IMC has taught us that we might be under pricing a little bit. But what we wanted to do is as we release this, we did use IMC as a way to bring this to market. So what we're offering is, you can see here, and if you look at, and if you've been with us for a while, and we appreciate that, is one of our commitments was to customer excellence, and we made a very bold decision to put all of our pricing on our website. So if you go to our website now, I can see the names of a lot of you on this call. A lot of you are strategic partners of ours that might have discounting in place. Our list pricing, if you will, is on our website. So we want to make sure we expose this pricing. So it is a subscription based. What we do is we offer all the hardware, all the software, the monitoring services, the battery replacement, everything into a package. So we'll install, we'll commission. If the battery needs to get replaced, that's on us. If one of the equipment fails that we supplied fails, that's on us to replace. It's on us to look at your data. When you're not looking at it, someone within our team is looking at that. They're waiting there, responding 24/7, looking for those alerts. We don't price per user or anything like that. So what we're offering to those from IMC is a 50+ POC. So what we found is 50 points is a great starting point to prove the value of the system. Typically, assets are between 3 to 4 bearings, so a pump, motor, pump, fan. So that gives us 12 to 15 assets we can cover over a 1-year period. It's completely risk-free. After that 1 year, if there's no value, that entire pricing is around $30,000 with service packs, with everything that come into play. So with the grease, everything like that. We feel that's a great partnership to test the partnership, to test the solution. So if you're interested in that, we're offering an IMC pricing strategy of 50+ proof of concepts for $595 per point. So you can do the math times 30, and the service packs are on top of that. And then after that 1 year, we do offer economies of scale. Now we do have customers now that are over the 1,000, over the 2,000 points. So there is beyond that large scale, but to give you an idea of what this would look like at scale, right? So obviously the more sensors out there, the easier we are to monitor, the easier are we to install and service, and we can do a lot of battery replacements at once. So there's some economies of scale, but we do want to get that out there from that perspective, that if you are interested, and this will be my next slide, if you're interested in this, I'm going to ask that you, sorry, I went out of that, that you go through and reach out to us. I'll pull the slide up here, and we'll open up a poll question that we can go through and talk about your initial ideas you have for applications, and go through a formal proof of concept plan together. So let me just pull this back up here. Okay, so you can see Mo?
Yeah, so you guys can either, I just put the link in the little chat, or you can scan that QR code and go to a form that you can fill out on our website to let us know that you're interested in having a more personalized discussion about this. But I'm also going to just quickly, in case you'd rather us just reach out to you, I'm going to just launch this quick little poll, and you can hit yes or not yet, and we'll know to reach out to you. So lots of different ways to let us know if you're interested in having some additional discussions. So definitely let us know one way or another, and we will gladly be in touch. Okay, perfect. So I will, looks like we're still getting a couple more people responding here, and then I will close this out, and then you guys will still have that option, you know, to either just to fill out the form on our website or, yeah, reach out to us directly as well. All right. So we do have a couple questions, Blair, that I'd love to toss over. And if anybody has additional ones, please feel free to get those in. I know we're getting close to the hour, and we don't want to take up any more of your time than necessary, because we, of course, can have conversations later. But just real quick, one person was wondering what type of grease does this system use?
Yeah, great question. We get that asked a lot. We're not a grease provider, so I incorrectly say I don't care what grease you use. I care that you use the right grease, but we are not tied to a grease provider. We can supply grease from most every manufacturer and have it in our single point lubricator. So we're not tied to a grease. So if you have a preferred grease type, we'll make sure we work with you on getting that into this lubricator.
Perfect. Okay. Kind of similar to that, mounting options. There's a couple of people actually that were asking about that. So for the sensor itself, I know you
Yeah,
kind of.
so it's great, and it really depends on the asset type. What we found is pillow block, still the epoxy likely works better from a mounting location point of view. You know, and again, we are ultrasound first, so we have a little more freedom from ultrasound than we do with vibration, because we're not looking at movement in a specific axis. So we have seen some unique mounting methods, but really there's three core. One is the epoxy stud mount, which gets epoxied onto the asset. Two is the grease fitting adapter. And three is the fin mount if we're using typically the non-drive end of a motor.
Awesome. And then, yeah, data is always of concern to people. So obviously you did a great job showing the UE insights and how all that data comes into there, and eventually even from the handheld ultra probes and things like that. But what about being able to pull this data into existing CMMS systems or ERP systems that people are running at their plants?
Yeah, great question. We do get asked that quite a bit, especially from enterprise level customers. So it is designed, and the way I'll describe it, and it's a bit over my head, but excuse me, is easy, pre-existing, secure APIs that are already built into the platform. So we have a document that we typically send to IT departments about you know, the availability of these APIs. We do have a discussion of what data you want. We can customize what's data coming out. Very, very common for us to integrate into CMS ERP systems to create closed work orders, things like that. And it's designed on purpose to do that out of the box.
Okay, cool. And then I was waiting for this one to come through, because I don't think we ever do a webinar ever where slow speed bearings don't get brought up. And sure enough, at the last minute here, someone was asking how this system works for our slow speed applications.
Low speed, yeah. So absolutely. So the lowest we've done that I'm aware of is 1.8 RPM, which is very, very slow. So the system works and anyone that knows ultrasound will know ultrasound and slow speed are very good applications together. What we do have to do is for slow speed is typically the vibration doesn't work at all. And anyone that knows vibration and slow speed would understand that. So while we still collect the vibration data, it doesn't often mean much to us. We rely solely on the ultrasound level. And in those cases for slow speed, you know, the considerations around mounting locations is more impactful. So this solution, and from the lubrication point, works very, very well for slow speed. Just know that we're not going to use the vibration, and the ISO limits we're not going to use. We're going to set up custom limits for lubrication, early warning, and critical failures of that bearing using non-ISO limits.
Perfect. Okay, well, we are right about at time. So just a reminder to everybody, we did record this. We will send the link out because this was a unique presentation for those of you that were at IMC. It won't be something you can find on our YouTube channel, so you will need to look for that link from us. And yeah, Blair, thank you so much, and thank you all for joining us. Again, it was great meeting you all or reconnecting with you all last week. And we are ready to chat more with you all about this, so don't hesitate to reach out, and we will also be in touch with those who asked us to be. So with that, everybody, enjoy the rest of your day. Have a great holiday if we don't talk to you before then, and we will catch you guys later.